We often see differentials in context of application problems, so let's do a few of these. First one, a store estimates that the revenue in dollars from the sale of X cases of soup is given by R of X equals negative 5,600 plus 9.4X minus 0.0041X squared. They want us to use the differential to approximate the change in revenue from the sale of one more case of soup when they're currently selling 1,200 cases. And we should round the final answer to the nearest dollar. Well, the first thing to notice is they're asking us to approximate the change in revenue. So that they're using capital R for revenue, so the change in revenue is DR, D capital R. And they want us to do the change in revenue, that's the differential. Remember the formula for differential is f prime of x dx. In other words, we've been using y's, but the fact they changed this to an r shouldn't matter at all. Just substitute r for what you've been doing with y. So we have to take the derivative of the revenue function as the first step. So dr equals, that's derivative would be 0. Then you get 9.4 minus 2 times 0.0041, which would be 0.082 x to the first, and then you multiply by dx. At this point, you simply use the information they gave you. They're currently selling 1,200 cases, and X is the number of cases, so they're telling us that X is currently 1,200, and they're asking us what would the change in revenue be if we actually sold one more case. So that means delta X would be a positive 1 more case. And remember, delta X and dx are the same. So really all we have to do to answer this question is to put 1,200 in for X and 1 in for dx, and we'll have it. So the differential, the change in revenue, the approximate change in revenue, would be given by this formula with the correct numbers plugged in, of course, 0.0082 times 1,200 multiplied by dx, which is 1. So 0.0082 times 1,200, if you do that on the calculator, comes out to be 3.36. So you get 9.4 minus 3.36 times 1. Oh, I've got an extra parenthesis there. Let's get rid of that. And that just comes out to be, if you take 9.4 minus 3.36, you get $6.04. They said to round it to the nearest dollar. Always just pay attention to how the rounding is requested. To the nearest dollar, that would be $6. Try another one. A spherical balloon is being inflated. Find the approximate change in volume if the radius increases from 5.7 centimeters to 5.9 centimeters. Now, the one thing that you absolutely have to know in order to solve this problem is what is the formula for the volume of a sphere. And it turns out that the volume is 4/3 pi r cubed. Now here I'm using an r instead of an x, and I'm using a v instead of a y. Shouldn't be any big deal. If you want to use a y and an x, it's all the same. But I like r and v because it reminds me of radius and volume. They're asking us to find the approximate change in volume. So they're asking us to calculate the differential of capital V. And of course we know that it's f prime of x, well normally f prime of x, but I'm using r instead of x, so it's really f prime of r times dr. If you'd rather go back and change these to x's and y's, it's fine. But basically I need to find the derivative of this function with respect to r. So the derivative, the differential of the volume would be 3 times 4/3, the 3's are going to cancel and just give me 4 pi and then the r third becomes r to the third minus 1 be r squared times dr. So that's the differential formula that you needed to solve the problem. They ask us to do this when the radius goes from what it was, which is 5.7, so they're telling us that x is 5.7, and it increases to 5.9. Now, they didn't tell us delta r, but they're telling us going from 5.7 to 5.9, so that's 0.2. And remember, delta r is the same as dr. So they didn't actually tell us what delta r was, but they gave us the information so we could find it ourselves. So those are the values that we plug in. So the differential for the volume is going to be 4 times pi times r, which is 5.7, squared, times dr, which is 0.2. Okay, make sure you've got it. So now it's an arithmetic problem. If you take 5.7, square it, multiply it by 4, then multiply that by 0.2, and I'll let you verify that on your calculator, you will get 25.992, and that pi is still in there, and the volume is in cubic centimeters, of course. They didn't ask us for an approximation, so I just left pi in there. Had they asked for an approximation to a certain number of decimal places, I would have used the approximate value of pi and done that, but they didn't ask for that. Another one. The population of bacteria in millions in a certain culture X hours after an experimental nutrient is introduced into the culture is given by this quotient. P equals 25x over the quantity 6 plus x squared. They want us to use the differential to approximate the change in population if x changes from 5 to 5.25. And they want to round the final answer to 3 decimal places. So this time we'll get a decimal approximation. So they want us to get approximate change in population. That's the capital P. So they're asking for the differential with respect to capital P. And we know, of course, that's f prime of x dx, and we are using x's over here now, so that is what I want to write. And that will be a quotient rule. So you take the denominator, which is 6 plus x squared, multiplied by the derivative of the numerator is 25, minus the numerator, which is 25x, times the derivative of the denominator, which is derivative of 6 is 0, so you're just going to get 2x, all over the denominator squared, which is the quantity 6 plus x squared squared. Of course, we want to simplify that a little bit. I think I'll multiply the 25 out through the parentheses. I've got 25 times 6, which is 150, plus 25 times x squared is 25x squared, minus 2 times 25 is 50, and x times x is x squared, all over the quantity 6 plus x squared squared. Now 25x squared minus 50x squared is simply negative 25x squared. So I can write this somewhat simpler. At this point, I want to use the values they gave me. They tell me it changes from 5, so that's what x is, and it changes to 5.25. So delta x is the amount of change, and if you take 5.25 minus 5, you can see that the change is 0.025. And again, remember dx and delta x are the same thing. So we want to take those values and plug them into the differential we just calculated. So we get differential of the population is 150 minus 25 times x is 5, be 5 squared, all over 6 plus 5 squared, all that quantity squared. So at this point, it's arithmetic. 5 squared is 25. 25 times 25 is 625. So you end up with 150 minus 625. 5 squared is 25. 25 plus 6 is 31, so you'll get 31 squared. And we're almost done. 150 minus 625 is negative 475 over 31 squared is 961. Now at this point you're going to notice, and I saw this a little bit earlier, but I decided to wait to show you that you just have to be careful. I don't have a dx in here, and the reason is when I got caught up in calculating this derivative, I just left the dx off. So no harm done. Just have to remember to go back and put it in. That dx has to be there. And you're going to catch it when you get to the point where you're trying to plug a dx in and realize you forgot it. So again, no harm done. So dx is 0.25. They want us to round it to 3 decimal places, so we can just use the calculator at this point. So if you take negative 475 and divide it by 961 and then multiply that by 0.25, you will end up with negative, remember it's a negative, 0.124. And this is in millions. So it's negative 0.124 million. In other words, just a decrease in population. The negative means the population is decreasing. Okay, one more. The shape of a colony of bacteria on a petri dish is circular. Find the approximate increase in its area if the radius increases from 20 millimeters to 29 millimeters. This is a very simple problem. I mainly threw it in to remind you that there are certain formulas you have to know to do some of these problems. It says the dish is circular, and they're asking about the area. So you have to remember that the area of a circle is pi r squared. From that point, it's very easy. We do the differential. dA, it's the derivative, and remember we're using r's instead of x's, so it'd be f prime of r times dr. The derivative is very simple, just 2 pi r times dr, and we take the values they gave us. It starts out at 20, the radius, and it increases to 29. So that means delta r is 29 minus 20, which is 9 millimeters. And remember, delta r and dr are the same. So all I have to do is plug those numbers in. The differential with respect to area is 2 pi times r, which is 20, times dr, which is 9. So you've got 20 times 9 times 2, that's 360. Pi. So the differential with respect to area is 360 pi. And area is in square units, so it would be square millimeters. They didn't ask for an approximation, so I just left the pi in there.